Hi, I'm Damian.
Hi, I'm Hannah.
And I'm Isa, and we'll be presenting on Problem A, kangaroo care. Okay, kangaroo mother care, which we will refer to as KMC, is a set of practices promoting skin-to-skin contact between human mothers and infants. It has a slew of psychological, physiological, and socioeconomic benefits, ranging from better regulation of stress, breathing, and heart rate, to promotion of good overall health for infants. And it is an inexpensive practice to include in early infant care. Our problem statement is as follows. To develop a model of the interactions between an infant kangaroo and its mother or human baby and its mother under kangaroo mother care treatment. Note that we're specifically focusing on humans in our model. We operated on several assumptions in the creation of our model. First, we are modeling responses of the infant's sympathetic, fight or flight, and parasympathetic, rest and digest nervous systems. We are only considering the first 720 hours of life. We assume no change to baseline levels of SNS and PNS activation, and that environmental stress is constantly present, and changes to SNS activation are proportional to the amount of environmental stress present. We are only examining the impact of the presence of KMC, sleep, and the presence of environmental stress or danger on SNS and PNS activation. For simplicity's sake, we are not accounting for factors like feeding. We are also assuming that quality of sleep is not impacted by SNS activation, and that failure to thrive occurs when SNS and/or PNS activation is unbounded.
So our model is actually based on another model that was proposed in 2009 by Stevens and Zhang on an infant's attachment development. And so they look at how the opioid system or like calm system and arousal system or anxiety system in infants is regulated by itself, right? So self-regulation. And then there's also terms for downregulation. So when one system downregulates the other system. And then also terms including the perception of external stimuli, whether it's good calming stimuli or anxiety-inducing stimuli. This system of equations is particularly useful for our model because the opioid system is analogous to the parasympathetic nervous system, and the arousal system is analogous to the sympathetic nervous system. And so we actually modified their system of equations in two major ways. The first way includes or accounts for non-zero baseline levels of SNS and PNS activation, which can be seen in the purple and pink terms. And then the second major change we made was actually specifying the stimuli that upregulate the PNS and SNS activation. For example, we assume that environmental danger and sleep upregulate the SNS and PNS activations respectively at a constant rate when they're present, and that KMC care, when present, upregulates the parasympathetic nervous system or PNS at a rate proportional to the amount of anxiety present. So if an infant is really anxious, then having KMC means that the PNS is upregulated a lot. Less anxious, less upregulation. For our model, we're assuming that sleep and the presence of K only take on values of 0 and 1, so they're there or they're not. And we assume that environmental danger can take on values between 0 and 1 in our model. But for our model, environmental danger, we're assuming it's constantly present, so it'll always be equal to 1. So before we do simulations, we wanted to look at the math of it to see what kinds of simulations to run. And when we look at the original model, we can write it as sort of this linear system of differential equations from which we get eigenvalues q equals negative mu plus or minus lambda. And this down the line signifies that the stability of the system. So whether or not there's a constant limit as we go to infinity depends on the relationship of lambda and mu. So we only really need to examine 3 cases of infants, whether lambda is greater than, equal to, or less than mu. And so these are the parameters that we used for our model. So we're going to walk through some of those simulations. So we simulated really 4 patterns of KMC care, and our first one was providing no KMC at all. And we can see that as long as the infant isn't a strong downregulator, they will approach an equilibrium at some point, and that's pretty desirable. we see that when we start introducing KMC, we approach an equilibrium slightly faster, and we're assessing that sort of qualitatively by looking at where the graph starts to get flat. And again, we reach a stable equilibrium, except in the case of strong downregulation. And it's the same song and dance for 2 hours of KMC every 12 hours, except we reach that equilibrium a bit faster, not significantly faster. And again, only in the case of an infant not having strong downregulation. And then constant KMC, so providing KMC 24/7. We reach an equilibrium almost immediately in the case of strong self-regulation. We reach it pretty quickly in the case of equal regulation. And again, there's no equilibrium in stronger downregulation. This has to do with the terms proposed in the original model.
So as proposed by the simulations, the initial spike in the SNS activation is pretty much very similar to the high stress infants face in the first moments of life after birth. A strong downregulation in infants downregulates the PNS so much that the SNS activation is asymptomatically infinite and results in a failure to thrive scenario in the infant. Babies struggle more with emotional regulation when not provided with KMC, which is supported by Nelson et al. In 2011, when they wrote that KMC in human touch is required to develop positive pathways in an infant's mind their first month of life. And nervous systems can't be negatively affected or activated as the models indicate, but it's not a giant issue because the baseline values can be modified upwards to maintain positive values of equilibrium. The simulation implies that an infant's ability to self-regulate is its predictor of thriving because a strong downregulation is incompatible with life in the first month in every single version of the simulation. Typical sessions of KMC don't create equilibrium in the first month unless the baby has strong self-regulation. However, KMC improves infant neurological function and consistent contact with the mother guarantees infant survival. The model suggests more KMC helps infants approach equilibrium. However, constant KMC is pretty impractical. The rankings we provided were based on the contextual resources required to sustain these levels of KMC. So we ranked the 2 hours of KMC twice daily first because it creates equilibrium within the first month while using a minimal amount of resources relative to the time of the parent providing the KMC. 1 hour of KMC fell in second because it uses a similar amount of resources but does not reach equilibrium in the first month in a situation where a baby does not have extremely strong self-regulative practices. And constant KMC is in third despite its ability to reach an equilibrium point quite early on in the baby's life because of the amount of resources required for the mother to provide this type of level of regulation. No KMC is fourth because while mathematically there exists an equilibrium where the infant has strong enough regulation to sustain itself, it is practically known to be detrimental and often results in high infant mortality. The limitations of our model are essentially the amount of factors present in the infancy of a baby. We don't evaluate the risk that congenital conditions pose to neurological development. Its development is not reducible to an NS activation, and we can explain SIDS or the failure to thrive with our simulation. Any connection with KMC and infant self-regulation is not accounted for either, and genetic differences in infant response to external stimuli act as constant variables and do not change as time proceeds. It also does not account for the cost, emotional or financial costs, for the parents who are promoting KMC. In the future, we want to understand SNS activation in high-risk NICU infants and refine the parameters to more accurately suggest timeframes that KMC should be provided. It might be beneficial to update the impact that stress SNS activation has on the benefits of an infant, which is sleeping or KMC, and analyze how effective KMC is in high-stress environments, which do not have consistent access to water, food, or shelter. It also might help to understand the biological connection between KMC stimuli and an infant's improvements in its cellular systems.
So just some quick acknowledgements. Thanks to our coach, David McGee. Thanks